Hello everyone and welcome on today's video. My name is Wouter Pere, I'm the founder and main developer of GHEtool Cloud, and today we will be discussing our newest feature of GHEtool Cloud version 2.3.1, which are tilted boreholes. But before we can dive into how you design a borefield with tilted boreholes in GHEtool, we first have to discuss some definitions. So let's get started with that. When we talk about boreholes, we have to define one way or another how deep they are or what the borehole length is. Now if you have the ground surface, typically you have 1 meter below the ground surface. You have our horizontal piping which connects all the boreholes, and at that 1 meter deep you will start having your vertical piping. So that's what's called the borehole length. So the borehole length is measured alongside the borehole itself. Now if you have the deepest point of your borehole, that's called the borehole depth, which is defined as the buried depth plus the borehole length. Now for most projects this is more or less the same, but if you start drilling under a building and the buried depth becomes, let's say, 10 meters deep, then there will be a significant difference between the borehole depth and the borehole length, which has an effect on the average ground temperature your borehole gets from the ground, which has an effect on the effective area of heat transfer, etc. So in GHEtool Cloud you will have the possibility to enter your information or your borehole borefield design with either the borehole depth or the borehole length, and it's important to know the distinction between both. Now if you go for a tilted borehole design, then we have two other parameters. So if we tilt our borehole away from the vertical line, that's called the tilt angle. And as you can see, the borehole length is still defined alongside the borehole itself. Now if you take a look at this borehole from the top, you can see that we have a certain orientation in which we have drilled our borehole, which is defined relative to the horizontal line measured counterclockwise. So these are four important definitions: orientation and tilt, but also the borehole depth and the borehole length that we will need when we hop over into GHEtool Cloud. So now we are in GHEtool. I've created a new project and I moved to the borefield tab. And here you can see three different tabs or subcategories. First of all, you can select your borefield configuration. We have a couple of pre-configured ones, and you have the option to create your own custom design. For every configuration you have a couple of inputs, and lastly on the bottom of the page you can see the coordinates of your borefield from a top view, but you can also press the 3D icon and see a 3D plot of your borefields, which in this case are just 4 regular boreholes. So the first thing I want to mention or draw the attention to is the box here. Do you want to enter the borehole starting at the ground surface or the buried depth? That's what we just discussed. So if we say, well, we want to enter the borehole starting from the ground surface, it's the borehole depth that we enter. So if I now, for example, set the buried depth to 10 meters and we go to our 3D view, you can see that the bottom of our borefield is indeed at 120 meters. And if I rotate the screen, you can see that that's a better perspective is indeed at -10 meters. But if I now say, well, I want to enter the borehole starting at the buried depth, and I say, well, let's make it a borehole length of 120 meters, you can see that the end is at 130 meters, where is it? Our buried depth is at -10. So this really makes a difference, this input box, so please be careful when entering your information there. So now let's jump over to our customized tab. What I want to do is I want to have those 4 coordinates as coordinates in this list here. What I can do is I can duplicate all the rows themselves manually and I change all the information, or I can just go to my rectangular configuration, click on the borehole and say yes, I want to convert it, and then you can see that you have all the borehole coordinates here. Now you also have the option to import your borehole coordinates from a CSV file or from a CAD or Revit document. We will create another tutorial on how you can do that. But for the moment we have a list of XY coordinates which have all the same borehole depth and buried depth. But when I say no, they don't have the same identical buried depth, you will see that there are 2 columns appearing, so you can change the depth and the buried depth for each borehole individually. So for example, when you have a project where part of your borefield is under a building, you can change the buried depth for that part of the borefield independently. And then you will see on your right that there is another option that appeared, which is new, and this are there inclined boreholes. And if you say yes, there are, then there is another column that appears for both tilt and orientation. Please notice that when you use inclined boreholes, the definition is always the buried depth. So this means that your borehole is always entered using the borehole length method, our definition. So what we can do now is, if we click on this bottom coordinate, we see these are the coordinates, the depth, and we can say, well, let's make it a tilt of 15 degrees with an orientation of, let's say, 90 degrees. Well, let's keep it at 0 to start with. You will see that there appears a line in the vertical or in the top view plot, and if you go to a 3D view, you will see that there indeed is a tilt in the zeroed orientation, let's say. So if I now go to the other borehole, and again 15, and now 180, you'll see that it points in the other direction, and we end up with a borefield that looks like this. So one thing to notice here is that for our vertical boreholes, you can see it's not that clear, but our lowest point is at minus 130 meters. But if we tilt our boreholes, they are less deep because the length is measured alongside the borehole. So in this way you can make the most crazy configurations you want. Let's say we make a tilt of 20 degrees here with an angle of 90, and then we have a configuration that looks like this. And once you have that, you can just calculate your field as you will always do, and you will end up with the similar results, temperature profiles, etc., but now with a more detailed borefield design. So I hope this video was interesting for you. It was a rather short video showing you how you can work with tilted boreholes in GHEtool Cloud. If you think this is interesting for you and for your colleagues, please share the video and subscribe so you will be notified when a new tutorial comes out. And I hope I see you next time. Take care. Bye.